This is Chapter 5, Analytic Trigonometry. We're going to go ahead and get started with Section 5.1, which focuses on using fundamental identities. If you're curious about the textbook we're using, I've linked it in the description to the video here, so let's just jump right into it. Now, the primary focus of this entire chapter is to use the fundamental identities to perform 4 specific tasks: to evaluate trig functions, to simplify trig expressions, to develop additional trig identities that are going to be useful down the line, and to solve trig equations. Here we have most of our familiar fundamental trig identities, beginning with the reciprocal identities that we have. So for sine, cosine, and tangent, their reciprocals are cosecant, secant, and cotangent, and you can see how each of them is represented as the reciprocal of its reciprocal. Then we've got the quotient identities, where tangent can be described as the quotient of sine over cosine, which means that the cotangent, being the reciprocal of tangent, would be cosine over sine. We've also got the Pythagorean identities right here in the middle, all 3, which is sine squared of u plus cosine squared u equals 1. 1 plus tangent squared u equals secant squared u, and 1 plus cotangent squared u equals cosecant squared u. And last but not least, we also have the cofunctions of complementary angles identities, which basically tell us that the sine of this angle is equal to the cosine of its complementary angle. Or if you want to read these equations backwards, you can also say that the sine of an angle is equal to the cosine of its complementary angle. Because again, pi over 2 is 90 degrees, and if you're saying 90 minus the angle itself, then that's going to give you the complement to that angle originally. Last but not least, we also have the even and odd identities, which tells us right here that sine, which means cosecant as well, is an odd function, which spits out the negative of the original function itself when you take a negative argument into the trig function. You can also say that the cosine is even because when you take a negative u, it gives you the positive result. So cosine of a negative number is going to be cosine of the positive version of that number. But because tangent depends on both sine and cosine, since it is the quotient of sine over cosine, then that means that if this was odd and this was even, then an odd divided by an even is going to give you an odd, which is why tangent is odd as well. Now, one thing that we can note in these situations, in any one of these trig identities that we're looking at, is that in previous cases, we've always seen the argument as a theta or an x, but in this case, we're looking at it like it's u. In all of these equations and all of these identities, that letter u represents potentially a real number or an angle measure or even a variable. It's basically a placeholder for all of the possibilities that a trig function can be used for.